Okay, perfect. Well, it's great to see some old friends on the session today, and I think some of you might actually remember a couple of these stories. I'd like to take you back about 50 years when the health aides in Alaska's villages had a problem. Their problem was communicating with doctors in regional hospitals, because that's the way that healthcare worked in Alaska villages back in those days. It was all based on a communication connection. And you can probably tell that this health aide is talking on a shortwave radio. That was the only way they had to do it. And shortwave kind of worked some of the time, but it wasn't really all that reliable. And it especially wasn't reliable when the northern lights were out, because the aurora is really an electrical storm in the ionosphere. It's a layer in the upper atmosphere, and that's the layer that shortwave transmission depends on. So a lot of times it really didn't work very well. And that was why a few of us traveled the state this way and this way to try to do something about the problem. But there was somebody else who actually was on to what turned out to be the best solution. And that somebody else is someone that I think some of you probably remember. It was none other than Augie Hebert. Augie was, of course, one of Alaska's pioneer broadcasters, even before Rick and me, right? Augie, in addition to being that pioneer in broadcasting, he was also an engineer. And he was also a really public-spirited guy, concerned about telecommunications, especially out in rural Alaska. So in 1961, Augie met the famous Wernher von Braun, who was at that time was with NASA, the National Aeronautics and Space Administration. And von Braun told Augie about a new technology that was on the horizon, which was satellite communications, using an Earth satellite to relay signals between different points on the Earth. And Augie was on it right away, because Augie knew that this was the technology that had lots of potential for Alaska, especially for rural Alaska, where he was really concerned along the lines that I just mentioned. So Augie became an advocate. He became a strong advocate for satellite communications generally, but specifically, Augie wanted to build a satellite Earth station in Alaska to demonstrate what was possible. So he worked all through the decade of the 60s to try to get an Earth station built. And it didn't really go too far in the early stages, but toward the end of the 60s, Augie teamed up with Senator Bob Bartlett, who was one of our two US senators at that time. And between the two of them, they convinced the Communication Satellite Corporation, ComSat, to build the first satellite Earth station in Alaska. And that was appropriately enough named the Bartlett Earth Stations. I think that it no longer exists, but it was around for many years. And I think some of you have probably seen that up there near Talkeetna. In the spring of 1969, the Earth station was under construction, and it was scheduled for completion in the fall of 1969. But during the spring of 69, Augie had a feeling that it really would be better if that Earth station came on the air sooner than later, because there was an event coming up in the summer of 1969 that Augie was really very interested in. Augie at that time owned a TV station in Anchorage. It was one of, I think, 2 or 3 stations in Anchorage at that time. And this was an event that Augie thought really should be broadcast live to the audience in Alaska. It was something that was scheduled to happen in July of 1969. In fact, July 20th of 1969, that's a date that you might remember. When I do this live, people always jump in and remind everyone else that that was the date of the first moon landing. That was the date that Neil Armstrong set foot on the moon. And thanks to the efforts of Augie and Senator Bartlett, it was in fact broadcast live to not only through Augie's TV station, but also through his competitors. He he was a business guy, but he was also a public spirited guy. And so he shared that broadcast with the other TV stations in Anchorage. That was just the kind of a guy he was. Well, within the next few years then, that situation inspired Augie and a few others to spearhead the idea of earth stations in Alaska's villages. And that was really the big breakthrough. So by 1975, we started to install these small satellite earth stations in villages all across Alaska. And by the end of the decade of the 70s, pretty much all the villages had these. We called them small earth stations. This is a dish that's 15 feet across. It was really a small earth station in those days because satellite earth stations were typically more like the big one in Talkeetna, and the smaller ones were actually kind of a technology breakthrough. We were the first place in the world that built a network using those kind of small earth stations. So by the early 1980s, the new earth stations had made possible different services in the villages. First and foremost was the medical communication for those village health aides, but also telephone service. At first, it was one phone per village. And I'm guessing that some of you might remember at some point lining up to make a phone call in a village. That was the way it worked when there was only one phone. Then starting with OTZ telephone and then some others, telephone exchanges were installed, and pretty soon, pretty much everyone in a village had access to a telephone if they wanted one. And then, of course, there was that television channel that many of us remember, one television channel going out to all the villages. And its name was memorable. It was RATNet. That stood for the Rural Alaska Television Network. So I'd like to say that by 1980, the villages had modern telecom services. I mean, a radio, a TV set, a telephone. It was modern telecom service as it existed, say, in 1980. And of course, as Helena mentioned, that whole story is told in my book, Finding Alaska's Villages. Some of you might have already read that one. But the main thing is that we had phone service in the villages. We had the other services that I mentioned. And within a few years after that, we had internet, sort of. So into the 1990s, the internet was becoming a thing. And in the villages, they could connect to the internet, but it was the same way that many of us, others of us were, which was by dial-up modems. And you can probably remember dial-up modems. They squeaked and squawked and got you connected, but really kind of a really very slow connection. And that was kind of where the villages were then, and villages stayed in that position for many of the following years. But as we entered the new century, of course, broadband came along, and broadband became more and more important to all of us. We all use broadband nowadays. As the slide says, broadband changed everything. But out in rural Alaska, not so much. Each village has its own story, of course, but the availability of broadband has continued to be a problem. I'm getting a message on my screen. Janine, does everything still look okay?
Yes, it does.
Oh,
looks
okay.
fine.
I see Rick with a thumbs up. That's great. So I guess with COVID in the past year and a half, I think that COVID has kind of made the situation, kind of brought it to the fore a little bit more than it was before then, because it's in that time that we've heard about students in the villages trying to do their homework using the internet, using broadband, but with the schools locked up, they end up huddling around outside the school in the middle of winter, just trying to pick up a Wi-Fi signal. And that has really kind of accentuated this whole problem of broadband in rural Alaska. Well, there are, of course, a whole range of technologies that are now available to provide broadband service. the terrestrial technologies, including microwave and fiber optic cable, we are told very often that how fast fiber optic cable is. It really is pretty much the fastest way you can transmit data. It's also the most expensive when you're talking about long distances. And out in rural Alaska, we have lots of long distances. So it would be great if everybody had fiber optic cable, but it just, so far, it just hasn't been economically feasible. Then you have the satellite technologies, the GEOs and the LEOs, and I'm going to explain the difference between the GEOs and the LEOs. The GEOs are the geosynchronous Earth orbit satellites. Those are the ones that we've all been using for decades now. The satellites are over the equator, 22,300 miles up, and that happens to be the altitude at which it takes 24 hours for the satellite to go around the Earth once, 24 hours. That's the same rate at which the Earth rotates on its axis. So that means that if you're on the Earth, and if you could see that satellite, the satellite would stay at the same position in the sky because it's going around at the same rate as the Earth is rotating. That's a geosynchronous Earth orbit satellite, or a geosatellite. And it's in a pretty high orbit. The newer satellites that are now coming on the scene are the low Earth orbit satellites, or the LEOs. Those are only a few hundred miles up. And at that altitude, they go around about once every 90 or 100 minutes. That, it turns out, is roughly the same altitude as the International Space Station, and it's also roughly the same altitude as that SpaceX rocket that just took those 4 people up. And that's been all over the news. So we're roughly at that kind of an orbit, and that's the rate at which the space station goes around, and it's the rate at which those new astronauts, I guess there's some controversy about whether they're going to get astronaut wings, but I really think they should. So anyway, those go around once every 90 to 100 minutes. So there are some pros and cons here. The geosatellites have a long delay, that long satellite delay. That's because for a signal to travel up to the satellite and back down again at the speed of light, it takes about a quarter of a second. And then and sometimes to make a connection, you might need more than one hop. So then it would be maybe half a second or a full second. And again, if you've ever been on a telephone connection going through satellite, you know just what I'm talking about. Also, everyone these days, I think, sees it when you watch TV news and you see the TV anchor ask a question of a reporter who's off at a distant location, maybe in the Middle East. And then from the time the anchor asks the question until the answer starts to come back, it seems to take a long time. And that's because of the satellite delay. The LEO satellites don't have that problem so much because they are much closer to the Earth, so the signals travel up and back much faster. And of course, some broadband and internet applications are sensitive to delay, and so that's a definite advantage of a LEO satellite. There's a disadvantage, though, and that is that a geosatellite can cover a pretty big region of the Earth from one satellite. So you can imagine a satellite hovering over North America, and it's beaming down on North America, and all of North America can get coverage, can get service from that satellite. With a LEO satellite, not so much, because the LEO satellite is going round and round. At any point on the Earth, it'll be overhead or within view for somewhere between 8 and 10 minutes. So if you're talking on a satellite connection, say with your satellite phone, that satellite will fall below the horizon, and you're going to need another satellite to come up to pick up the connection. So there's kind of one advantage of LEO satellites and also one disadvantage of LEO satellites, because to provide continuous coverage with LEOs, you need a whole constellation of satellites. You need a whole group of satellites. And that's illustrated by one company, Iridium, which has a network of these LEO satellites for about 20 years now. My full disclosure is I'm on the board, on the Polar Advisory Board of Iridium, but I'm actually neutral on the subject at hand, broadband, because Iridium does not provide broadband. Iridium is just an example of a LEO system, but it doesn't provide broadband. So you probably have used Iridium if you've talked on a satellite phone, or if you used a Garmin InReach device. Either one of those uses the Iridium satellite network. And here's what that constellation looks like in motion. This is a constellation of 66 satellites, 66 operational satellites. You can see them going around there from South Pole to North Pole and back again. You can see the Earth rotating under those orbits. And you can see that the coverage areas represented by circles provide continuous coverage all the way across the surface of the Earth. So the LEO constellations, the new LEO constellations, provide the promise of providing not only broadband service, but also with the advantages that I described and continuous coverage of the Earth. And the two companies that already have LEOs flying are Starlink and OneWeb. You've probably read about those in the news, especially Starlink, which is a division of SpaceX. That's Elon Musk's company. So they've been very much in the news lately. And I think it'll be clear, it's probably already pretty clear why that is, because they have the promise to provide broadband, not only in urban areas, but everywhere on the surface of the Earth. So we now have 3 LEO systems in operation: Iridium, which has those 66 satellites in operation, plus 9 more spares, but that's mobile and portable service. That's not broadband. Starlink and OneWeb are the 2 companies that are either now providing or will very soon provide broadband, but not to mobile stations, but only to fixed stations. Starlink has 1,800 satellites up. These numbers are sort of amazing. 1,800 satellites with plans to ultimately launch 12,000 satellites. OneWeb has 218 satellites up at last count, with plans for 648, but both of them are getting into the same business, which is to provide broadband primarily to fixed stations. So here's a picture of the Starlink constellation when all of the satellites are in orbit. It's pretty striking, right? It looks like a swarm of bees, and it really kind of emphasizes the density of the objects that will be flying up there. But at the present time, Starlink only has 1,800 satellites in orbit, and they're not in the same kind of polar orbit that I showed you earlier with Iridium. Those satellites were orbiting from South Pole to North Pole and back, but the Starlink satellites that are up right now so far are in what we call an inclined orbit. In other words, they don't reach all the way to the north and the south. As Alaskans, the first thing you'll notice is Alaska is not covered by this constellation. More on that in a minute. But that's the Starlink system that's in operation right now. To get service from that, if you were in their coverage area, for example, you would need a little dish antenna like this one. So that's about 3.5 feet across. And you need some electronics. And that's how you get service from Starlink. Some people are already doing it because quite a number of months ago, Starlink announced what they call a beta project, in other words, a trial project. And they offered that in the beginning to the so-called northern tier states. That doesn't include us. That would be the northern states of the South 48, so places like Michigan and Minnesota. And they promised 100 megabits per second uplink on the uplink and downlink. If you speak bits and bytes, you know that 100 megabits per second is pretty darn fast. It's not the fastest in the world, but it's way up there. It's definitely broadband. But what users are actually experiencing isn't exactly 100 megabits. Some of them, it's kind of dependent on the amount of traffic that's on the system. So some people are getting more than 100 megabits per second at a time, but then others are getting substantially less, maybe down even around 30 megabits or 40 megabits per second, which is, it's not 100, but it's still broadband and it's still pretty good. in Iridium's, people are interested in Starlink's pricing model. Their price for service in the trial and even continuing on to full operation is $99 a month. So these are the prices they announced for the trial, but they're sticking with these prices. $99 a month, no data caps, so unlimited data. But you also have another one-time cost, which is for the terminal, the electronics and the dish antenna that I showed you. And that's $499 self-install. So they've got it designed so anybody can install it. That's what they say. It seems to be working so far. And so that's your price, is $499 one time plus $99 a month. Now, since that announcement quite a while back, Starlink has extended the trial to include 14 countries, including the ones on the slide. And then they announced a few months ago that they would be providing worldwide service this month in 2021. But I put worldwide in quotes because you just saw their orbit. So if that's the orbit that they're in, they're not really providing service in the far north or the far south. So I can only assume that by worldwide, they mean where most people live, but not all people. Anyway, not to worry too much, because Starlink has plans to provide service to Alaska and other regions next year, 2022. And there's no clarity on exactly when next year, but what they're planning to do is they're planning to launch more satellites that are in a higher inclination, in other words, closer to a polar orbit, and then that will actually provide service in the far north and the far south. So switching over to OneWeb, if you have a picture of their full constellation, it looks like this. It's not nearly as dense as the Starlink one, because there aren't so many satellites, and also because they're in a higher orbit. Right now, they have 218 satellites up there. That's enough to provide continuous coverage. And so customers always wonder, well, what are OneWeb's plans? And their plan is to provide service in the far north, in the Arctic region, which is us, late this year. So that means that actually, although Starlink has more satellites up there, OneWeb, according to their plan and their announcement, will be providing service to Alaska earlier than Starlink. So that's interesting. And then they say that they'll provide global service by the end of 2022. So that's all pretty interesting and pretty helpful for, especially for people that live in rural and remote areas. The pricing is intended, Starlink's pricing, the $99 a month, is intended to be competitive with what people pay in urban areas. And I guess at least they're in the ballpark. But there are some issues, and these are issues that interest me and some of my academic colleagues. One is light pollution. And here's how that goes. If an astronomer is looking through an optical telescope and trying to see some dim object that's far away, he or she may instead see a very bright object in the sky, which is a Starlink satellite on its way to orbit, and its solar panels are reflecting sunlight, and so that looks like a bright object. You might have seen some photos somewhere that show a whole parade of satellites all looking like bright objects in the sky. So that's one issue. Starlink says they have a solution to that. Not sure what it is. Some kind of a shield, I think. We'll find out more about that. Another issue is the space junk problem. And I bet some of you were already thinking, when I showed you that picture of the Starlink constellation, I bet you thought of this right at that moment, which was, with all those satellites flying around up there, and there are lots of other objects up in low orbit beyond the ones that I've been talking about, it seems like there's a probability that at some point there's going to be a collision. And even worse than a collision would be a chain reaction, where a collision throws off fragments, then those fragments strike other objects, and so on. If you saw the movie Gravity, that's what the movie Gravity was about. Now, I will say that all these objects in space are being tracked, and companies that are operating these satellites are notified of potential collisions, and they do, to some degree, have the capability to steer and to avoid collisions. But I think that nevertheless, this continues to be an issue. The whole chain reaction thing, that's what's called a Kessler event. And so there is still quite a bit of concern about this. And then the third one is radio interference. And that's the one that I and my colleagues have been working on, because it turns out that the FCC and the international regulators have assigned the LEOs and the GEOs to all operate within the same radio spectrum. Or actually, probably to say it a little more precisely, is the GEOs were already operating in this spectrum, and now the LEOs come along and the LEOs are assigned to use that same spectrum. So there's the problem of interference, of LEOs interfering with GEOs. That's one that's being worked on. And then there's also the problem of LEOs interfering with each other, which means that somehow they have to figure out a way to share the spectrum so they don't cause problems to each other. So that's a quick overview, I guess, starting off with a little bit of history about how satellites have helped rural Alaska in the past and how they may be able to help with the broadband problem, but really in combination with the other technologies that I mentioned, like microwave and fiber optic cable. So I'll stop there and ask if you have any questions.